Looking at now the equation of a circle, and we're going to try to determine the equation and as well sketch it and see what it looks like. So what we're given is that the point 3,2 is on a circle. Now, we do have to make an assumption here, and that assumption is that my circle is centered at the origin. So right in the middle is the center of my circle. And I'm told that the point 3,2 lies on the circle, so that means I go across 1, 2, 3. I'm going to erase these points, don't want to confuse them with the origin, and I'm going to go up 1, 2. So 1, 2, here is my point. So if that is a point on the circle, the outer edge, and this is my center, this obviously is going to be my radius. And again, excuse my terrible drawing, but if I were to continue this all the way around, it looks like what I get is a nice uniform circle as best as I can. And there you have it. So I'm actually answering the second part in terms of sketching it, but I want to see a detailed equation of what it looks like first. So we know that the equation of a circle is given by the equation r squared, which is the radius, is equal to x squared plus y squared. And in order for a circle to be determined, what we need to know is just its radius. So how do I determine the radius if I know that a point lies on the circle? Well, let's go back to our diagram and take a look how the radius is related to the point on the circle itself. So here's our radius r. Now if you recall, we went across 3 units. So I went from the center all the way across 3 units, and then I went up 2 units. Lo and behold, look at the shape that we formed. It's a right angled triangle. Now if this here is 3 and this here is 2, it's no surprise that our radius is going to be the hypotenuse of this right angled triangle. So essentially that is what the equation of a circle is. It's the Pythagorean theorem, but you're rotating the points all the way around in a circular pattern. So if I want to figure out that radius, I literally just plug in the values of 2 and 3 into my equation and solve for r. So let's take a look. I have r squared equals 3 squared, because that's my x term, plus y squared, well, y is actually 2, so plus 2 squared. That gives me 9 plus 4 is equal to r squared. Keep going, r squared is equal to 13. If I want to figure out what the value of r is, I take the square root of these two guys, and that tells me r equals root 1, 3. Okay, if you wanted to actually take the decimal of that, so I'd have to go to my calculator and do the square root of 13. Again, make sure you know how to use yours. You end up getting 3.06, and that's an approximate answer. So 3.605, so let's say 3.61. It goes on forever. It's an irrational number, but that is our radius exactly. So if I wanted to draw 3 other coordinates that are also on this circle, well, I can actually draw 4 if I really want to. So 3.61, my radius, and that actually shows that my circle is off, is going to be roughly here. It's going to be roughly here. It's going to be roughly here and roughly here. So to draw a more accurate circle, I should actually have it going like this. Okay, and these points help me trace it out. Again, not a perfect circle, but it renders the idea quite well. And there you have it. One thing, though, actually, I didn't really answer part 1 because it says determine the equation of the circle. I mean, once I have the radius, I can essentially determine the equation, because the equation is just the radius squared is equal to x squared plus y squared. And we know that root 13 squared is just 13. And there you have a simplified version of the equation of your circle.